Hello, everyone. Welcome to Team Resolution. Today, we're going to be talking about fluorescent microscopy, what it is, and how it works. Our presenters today will be Brianna Wing, Lowell Bennett, Terry Tom, Lauren Bennett, and myself, Kalani Ewing. And on the agenda today, Brianna will be talking about what is visible light. Kalani, will be talking about what is fluorescence. Lowell will be talking about what is the Jablonski diagram. Terry will be discussing how does a fluorescent microscope work. And Lauren will be discussing and identifying what are filter cubes. So up next, we have Brianna Wing, who will be discussing what is visible light. Brianna?
Thanks so much, Kalani. I appreciate it. What is the visible light spectrum? The spectrum is the segment of electromagnetic spectrum that the human eye can view. We can look at the colors in this visible light spectrum and see that the visible light is in between the UV and the infrared. It starts with gamma rays, X-rays, then UV, and then visible light. Next is infrared, and then radio waves. Next. Up next, we will be watching a quick video that I think that shows what visible light is really well.
All electromagnetic radiation is light. Visible light is the only part of the spectrum you can see. For all your life, your eyes have relied on this one narrow band of EM radiation to gather information about your world. Though our sun's visible light appears white, it is really the combined light of the individual rainbow colors with wavelengths ranging from violet at 380 nanometers to red at 700 nanometers.
Great, thanks, Terry. So what happens when light hits matter? Absorption, the reduction of amplitude of one or more wavelengths. You see whatever's left as transmitted or sometimes reflected light. If the light's fully absorbed, then the light is not transmitted. Next. Next up is Kalani. Kalani will discuss what is fluorescence.
Thank you, Brianna. Hello, everyone. My name is Kalani Ewing, and today I'll be talking about what is fluorescence. Fluorescence is where the light source and the objectives are on the same side, hitting the specimen with light of a certain color. In order for fluorescence to occur, there has to be a molecule in your specimens that is able to fluoresce. This molecule is called a fluorophore. Each fluorophore responds to a certain excitation color. In this example, we'll say blue, and it produces a certain emissions color, which is green. Now, different fluorophores absorb and emit different colors. As you can see in the picture, the fluorescence image, here to the left, it has different fluorophores, which are basically different colors. We have some blues, yellows, greens, etc. And what the blue light does is it hits off of the fluorophore, which absorbs the light, which then emits to the green light, which is the emissions. So yeah, that's what a fluorescent is. And up next, we have Lowell Bennett, who will be discussing the Jablonski diagram. Lowell.
Thank you, Kalani. Yes, what is a Jablonski diagram? Well, Kalani talked about absorption and emission, and a Jablonski diagram is a way to see that graphically. The picture you see here shows if you start at a ground state for a fluorophore molecule, we'll start at a ground state, which we'll call S0. When light of a certain energy hits the fluorophore, it excites that molecule and elevates it up to what you'll see as S1 prime, which is the excited state. And you can see it also indicated by the number 1 as an excitation process. So that elevates or excites the molecule to the higher level, an excited state, and it stays there for a very short lifetime. As you can see, number 2, it starts immediately to lose some of that energy on the order of 10 to the minus 9 to 10 to the minus 8 seconds, which is about a billionth of a second. As it starts to lose that energy, all of a sudden it loses a lot more of its energy and goes back down to the ground state. So it goes from S1 down to S0, which is the step 3 you see there. And in the process of doing that, it emits light of a different color, a fluorescence emission. And the fluorescence emission is visible, and that is what we see in the various fluorescence diagrams. Every fluorophore absorbs light of a certain color and emits light of a certain color. And we choose different fluorophore molecules depending upon the image we're trying to see. Now, how does all this work within the actual microscope? Terry is going to talk about that next. Thank you.
Thank you, Lo. So my name is Terry, and I'll be doing a presentation on how the fluorescent microscope works. So basically, when you get your specimen, you need to stain it with a certain fluorophore, whether it be Alexis 88, GFP, DAPI, or Texas Red. For my example, I'm going to be using the common fluorophore of GFP. So once the specimen is stained with GFP, you'll stick it on the microscope stage and you'll turn on the light source. So the light source produces a visible or non-visible radiant energy for general illumination. So when that happens, it'll go through the excitation filter, and the purpose for the excitation filter is to filter out specific wavelength of light. Once the specific wavelength is going through the filters, it'll hit the diachromatic mirror. And the point of the diachromatic mirror is to direct the selected excitation wavelength or color through the objective lens onto the specimen. So as you can see, it'll travel down, it'll hit the specimen, it'll excite it, and it'll emit the green light up to the objective. And the objective purpose is to magnify enough to see them in great detail. It'll keep on going up past the dichromatic mirror up to the emission filters. And part of the emission filter, the purpose of the emission filter is to allow the particular fluorescent from the objects to reach the ocular and block all unwanted excitation light. So it'll keep on going up to the ocular, and the purpose of the ocular is to magnify the image produced by the objective lens. When that happens, you'll see your image with the GFP, and that's how the microscope works. So next, Lauren would be talking about the filter cubes.
Thank you, Terry. My name's Lauren, and I'll be talking about what a filter cube is and how it works. So the filter cube is a cube that houses an excitation filter, the dichroic mirror, and the emission filter. The filter cube filters the light color that you want to see from your specimen. The white light from the light source goes through the excitation filter, is then filtered through the dichroic mirror and sends it to the specimen. Light is then emitted from the specimen and comes back up through the mirror and through the emission filter and finally to the camera. You do need different filter cubes or filter sets for each specimen that you would like to view or see. Thank you.
All right, thank you everyone in Team Resolution. That'll be it for today, and we would like to thank everyone for viewing our PowerPoint slide. Have a good evening.
Team Resolution.
Team Resolution.
1, 2, 3.
Thank you.
Resolution.
Resolution.
Thank you.